Black holes are among the most fascinating objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are invisible to our eyes, but we can detect them through their effects on nearby stars and gas. Black holes form when massive stars collapse at the end of their lives. Around the singularity is an invisible boundary called the event horizon. Once something crosses the event horizon, it can never escape. Black holes are incredibly dense and massive objects. Stars are giant balls of hot gas, powered by nuclear fusion in their cores. As a star runs out of fuel, its core contracts. For massive stars, this collapse is dramatic and violent, resulting in a supernova. What remains is a stellar remnant of incredible density, a black hole. The gravity of this remnant is so strong that not even light can escape. This is why we call them black holes. Black holes are famous for their extreme gravitational pull. But what would actually happen if you got too close to one? The answer lies in a rather unsettling phenomenon known as spaghettification. Imagine an astronaut falling feet first towards a black hole. The gravitational pull on their feet would be much stronger than the pull on their head. This difference in gravitational force, known as a tidal force, would stretch the astronaut out like a piece of spaghetti. The closer the astronaut gets to the black hole, the stronger these tidal forces become. Eventually, the stretching would be so extreme that the astronaut's body would be ripped apart into a stream of atoms. Spaghettification is a consequence of the extreme curvature of space-time near a black hole. It's a stark reminder of the immense power of these cosmic objects. Tidal forces, the architects of cosmic spaghettification. To understand spaghettification, we need to grasp the concept of tidal forces. These forces arise from the difference in gravitational pull across an object. It's not just the strength of gravity that matters, but also how it varies over distance. Imagine the Earth and the Moon. The Moon's gravity pulls more strongly on the side of Earth facing it than on the opposite side. This difference in gravitational pull creates tides in our oceans. Near a black hole, tidal forces are amplified to an extreme degree. The gravitational gradient is incredibly steep. This means that the difference in gravitational pull between your head and your feet, even if you're just a few meters tall, would be enormous. These extreme tidal forces are what cause spaghettification, stretching and tearing apart anything that ventures too close to a black hole. A matter of scale. Spaghettification in different black holes. The intensity of spaghettification depends on the size of the black hole. Smaller black holes, with their more concentrated gravitational fields, have stronger tidal forces near their event horizons. Imagine two black holes, one the mass of our Sun and the other 1,000,000 times more massive. You wouldn't want to get too close to either of them, but the smaller black hole would actually be more dangerous in terms of spaghettification. Near the supermassive black hole, the tidal forces would be gentler, at least initially. You might even cross the event horizon without being stretched into spaghetti. However, you would still be doomed to fall towards the singularity. In contrast, near the smaller black hole, the tidal forces would be much stronger. You would be spaghettified long before reaching the event horizon. Beyond the event horizon, the journey's end. The event horizon of a black hole is a point of no return. Once you cross it, there's no coming back. Not even light can escape the black hole's gravitational pull. As you fall towards the singularity at the center of the black hole, you would continue to be stretched and compressed by the ever-increasing tidal forces. Your body, now a stream of atoms, would eventually be crushed into the singularity. What happens at the singularity itself is still a mystery. Our current understanding of physics breaks down at this point. Some theories suggest that you might emerge into another universe, but this is highly speculative. The journey into a black hole is a one-way trip to oblivion. It's a stark reminder of the vastness and mystery of the universe we live in.